Okay guys, so for video notes, I generally don't do much lecture in this class because this is an inquiry-based class, but in many cases, there are ways that I need to convey information to you that cannot be done via inquiry. Like for example, describing what a CER is. So that's what video notes are for. This one is a newer video notes that I made after I made the next video notes you're gonna watch. So in the next video notes, I go over all the benefits of why I record instead of talking it over with you guys in class. So just like watch that one first if you wanna know why we do uploaded video notes instead of me lecturing in front of you in class, okay? But I'm not gonna go over like the exact same thing there. I am just going to now talk about this little lecture. Those of you who have taken me for general biology or have taken chem already know exactly what CERs are, and this will be a refresher for you, but you should still watch this because there are differences between CERs and chem and regular bio with AP bio, like huge differences. What is a CER? It stands for claim, evidence, and reasoning. It is a way to write down like almost like an essay or a lab report without it being in an official essay or lab report format. So we prefer this because it really helps you, like it forces you to justify all your claims with evidence and reasoning because you're writing in this format. So basically anything you say in science has to be backed up by either data you gathered in the lab or by like a scientific fact that's already well established because somebody else gathered that data and proved it, right? So writing in this format makes you prove everything you say, which is basically the important thing in all sciences. That's why we love it so much. A claim is the answer to whatever scientific question you're answering. Every single experiment that is a good experiment is answering a scientific question, right? You're answering, does this drug work to cure COVID? Or do these plants suffer more under the effects of global warming than not, right? And then your claim needs to be a one-sentence, short, succinct, stand-alone statement that answers that question. So for example, you cannot have a yes or a no in it because you need to be able to read your claim by itself without knowing what the question is and be able to infer what the question is from that, okay? You are absolutely never allowed to use I, we, first or second person statements in science when writing any sort of lab report until you get to the super high levels and then you can break those rules, but not in my class. In science, what we're pretending is that we are impartial observers without bias. So when we describe the results that we got or what we did in an experiment, we describe it in terms of this was done. So we use the passive voice, which is odd because your English teachers always say no, never, right? But in science, you have to use a passive voice because you have to pretend that every single other person in the world can do the exact same thing you did and have reproducible results. So it's not a personal result, it is like a universally attainable result. That's the way I like to explain why we never use personal pronouns. Then finally, unless you are designing like a very horrible experiment that should not be done, you should probably have an independent variable and dependent variable in your experiment. And the claim usually is going to talk about how those two are correlated. Is there a negative or positive correlation, etc. Okay? So the next thing is, the claim is really short, it's just one sentence. The next thing you have to do is provide evidence to support that claim. So what is evidence? Evidence is only stuff that's actually relevant to what you're doing, okay? What does that mean? That means that if you are running a lab where you collected multiple pieces of data and then realized that one of the experimental groups you had was totally like useless, you would never include the experimental data from that group as your evidence because you're not using it. When we look at evidence, we're looking for necessary, aka actually useful, and sufficient, which means you can't leave anything out in your evidence that you actually use to come up with your conclusion or claim. What I see kids do a lot of the time is they think, oh, I can present one piece of evidence. Like if I measure temperature at multiple times and then also measured like the rate of reaction at that time, I'm only going to include one, the most important data point. No, you need to include all of it if it helped you reach your conclusion. And that's what we mean by sufficient, okay? Appropriate, that's the necessary part. And then evidence can be either qualitative or quantitative. You should both know both of these words by now. Qualitative is anything without numbers. Quantitative is anything with numbers. Finally, the reasoning, probably the most important part of a CER or any type of scientific lab report or analysis. This is where you are actually explaining how your evidence proves your claim, okay? Because you can't just say evidence and say, oh, and that's why my claim is true. There's got to be some scientific principles behind what you're talking about. For example, if I'm saying that temperature is going to increase reaction rate, I better include in my reasoning all the stuff about kinetics, right? I need to discuss how increased temperatures will break intermolecular forces, allowing my molecules to move more quickly because they're no longer constrained by attractions to other molecules. I need to explain that temperature rising increases kinetic energy, which also increases the chances of collision between my reactant molecules, which would speed up the reaction rate. A lot of times people will just repeat their claim and be like, and this is because of my evidence. No, it's not. You need to also explain what part of your evidence is supported, like what is its relationship to the actual science that you're learning here, okay? For this should be pretty much like the crux of your CER, because this is the most important part. You're explaining how the whole thing works and why it works, okay? And this section should contain both principles, like I talked about, scientific principles that have already been established. Like, for example, everybody knows what hydrogen bonding is. Everybody knows what natural selection is. Everybody knows what directional selection is. Those are scientific principles that you can use to justify why your evidence supports your data. You also need to explain how all of this stuff ties together. That's the connection. So how does the principle support, or how does the evidence prove like a principle or is supported by a principle, and how do both of those together prove that your claim is correct? This one people miss a lot. A lot of the times they'll just state facts over and over again and be like, yeah, that proves it. No, this is like a because statement that you need to include in every single CER. Why do we do CERs in AP Bio? Because of Science Practice 6, which is one of the most common science practices to appear on the test and also one of the harder ones. This Science Practice 6 is literally about argumentation. Oh, look at the word claim there. Ooh, look, evidence, principles, what? Reasoning? Okay, the first 3 bullets out of the 5 bullets that make up Science Practice 6 is literally CER. And on many FRQs, you will be asked to write out like argumentation, CER type things. So in my class, what we're going to do is we're not using those T tables anymore like we did in chemistry, because we can no longer afford to have bullet pointed statements or fragmented thoughts. In AP Biology on the FRQ, which is worth half of your test, you will receive literally 0 points if you write an incomplete sentence in any way, shape, or form. I am an AP reader. I can guarantee you this is true because these are the instructions I receive every summer when I grade your tests. We are also going to be using them mostly for labs. So it's not going to be like you have to write them all the time. But the way they're going to be done in labs is also going to be slightly different. It's going to be like, you're going to have the claim on your poster, but the rest of the CER, I don't really want written much of it. You're going to be verbally explaining it to the class. So that makes it even more important that you have a coherent thought process linking together all the aspects of the CER, because you have to verbally explain it to your classmates, okay? And I do this for a very specific reason. If you just write down the stuff, sometimes one group member will write that all out, and then other group members who don't understand how the connections happen will read it aloud. But I want you to be able to all extemporaneously state what the whole CER is in front of a group, okay? So what are you doing now? Now you shall be doing the farming prompt about the guy and the frost and whatever. You're going to do the highlighting there and then evaluate what you would grade the CER as. Once you're done with that, come show me as a group, so I know that you've all completed that as a group. Then on the back side, now you're looking at hospital hygiene techniques. For this one, you're going to write your own CER. And then once you're completely done, you can turn that into the turn-in bin. Your next task will be to start on the video notes for hypotheses and statistics, and that's where you're also going to start learning about how to write FRQs as well. All right.